Okay, kindly solve this problem number 51 from exercise 5.1 from the book Fundamentals of Physics 10th edition extended version by Halliday, Resnick, and Walker. Okay, Josh.
So here, this is what we call Atwood's machine. So there are two blocks connected by a rope, and they're just connected by a pulley. So what is this used for? I don't know. But most of the, what people have been, I don't know. Genuinely, I don't see a use for this. But physicists have been using this to measure acceleration, because the masses are known and uniform, and the rope is very thin in the real world Atwood machine. So we can effectively calculate acceleration. Moreover, the gravitational acceleration. So this is one of the experimental methods how to determine the gravitational acceleration, which is 9.8 meters per second squared. So here we know that the first mass is 1.30 kilograms and the other one is 2.80 kilograms. What is the magnitude of the block's acceleration and what is the tension in the cord? Assuming that the cord is massless and the pulley also has no mass and is perfectly frictionless. So let's draw a free body diagram. Free body diagram first. So there's the first tension force, and of course it's accelerating upward because it's much less massive. So the other one will fall down, and this smaller mass will go up. So that's the gravitational force. And then for the second mass, we also have tension, and we have the second gravitational force, and of course it's accelerating downwards. So now for A, using using Newton's second law, we can say that F1 is equal to m1g, of course, and F2 is equal to m2g. Using the free body diagram in figure 1 in Newton's second law, we can say that F net 1 is equal to m1a, which is equal to P, tension. So for m for mass 2 is equal to m2a, which is m2g minus tension. Why? So for the first mass, the tension is going up and the mass is going down. So of course the force of gravitation is going down. The tension is pulling it up. So therefore, tension should be positive and the gravitational force should be negative. So why in the second equation, why is the mass positive even if it's going down and the tension is negative when it's going up? That's because acceleration is going down. So therefore here actually it should be negative m2a is equal to the same thing, which is supposed to be p minus m2g, but oh well, so the negative sign was transposed. So now this is the negative, which is tension, and this is the positive, which is the gravitational acceleration. So thus, by summing both of the equations, m1a plus m2a is equal to m2g minus m1g. Okay, simple. P was being cancelled because it's not necessary. M1 plus M2A is equal to M2 minus M1A, and then simplifying it, we can isolate A. Now, using the values provided in the problem, we can evaluate A. That is 3.585 meters per second squared, or 3.6 meters per second squared. From 3, we can calculate tension. So tension is equal to this. 1.30 kilograms times the gravitational acceleration plus its actual acceleration, which is 3.6 meters per second squared. So now we can evaluate that into 17.42 newtons or 17.4 newtons. So the acceleration of both systems, actually, not really both systems, the acceleration of the first block is 3.6 meters per second squared, and the acceleration of the second block is actually negative 3.6 meters per second squared. Why are their accelerations the same? Not because of the Newton's third law, but because this cord is massless. If the cord was not massless, and there was no there was friction in the pulley, then definitely their accelerations won't be the same. But now their accelerate the absolute value of their acceleration is 3.6 meters per second squared, and the tension in the cord is 17.4 newtons.
Nice. Thanks for
Thanks for
watching.
watching.
Good job, Josh.